Hello everyone, and thank you for joining ACEEE's webinar, Complying with the Clean Power Plan, an Opportunity for the Industrial Sector. My name is Cassandra Cubes, and I will be moderating and presenting on today's webinar. And before we get too far, a few words on some administrative issues. All of you are on mute on your phones or computers, whatever you dialed in on. So if you have questions, we ask that you please type them into your chat box as soon as you think of them, but we will be holding all questions till the end of the webinar, probably the last 15 minutes or so. Also, we are recording this webinar, and we'll be sending out a link to view the recording and a link to the PDF of the slide deck to all those who have registered for the webinar within a matter of weeks after today. So first, a few words on ACEEE's webinar series called Energy Efficiency and the Clean Power Plan. We introduced this series a few months back with the purpose to explore the opportunity for energy efficiency to be used for Clean Power Plan compliance. And each of the webinars highlights our latest research and emphasizes best practices in efficiency programs and policy design. And these webinars feature presentations from our program staff and from our Clean Power Plan team. The upcoming topics are listed here. The next one in June will be on the topic of paying for Clean Power Plan compliance. And then our last webinar will be a people's choice. So it's up to you to choose the topic, and we will have choices for you to choose from soon. Previous webinars, the one last month, talked about investments in the low-income energy efficiency programs and how to expand those to be used for Clean Power Plan compliance. And you can see a link to that webinar and our other webinar that we put on a few months back on the link that you see here on this slide to our Clean Power Plan homepage. And today's webinar will focus on opportunities in the industrial sector and how these investments can contribute to emission reduction. Here you can see our webinar speakers. We'll first be hearing from Megan Kelly, who is a senior research analyst for our industry program at ACEEE. She conducts research and outreach on the impacts of state and federal energy efficiency programs and policies on energy use in the industrial sector. She is also engaged in research on combined heat and power and intelligent efficiency. And Megan will be discussing the significance of the industrial sector in contributing to energy savings and the value of industrial programs. And I am Cassandra Cubes, a research analyst focusing on environmental policy at ACEEE. And as part of our Clean Power Plan team, I conduct research, analysis, and outreach on opportunities for efficiency to reduce air pollution. And today I will be discussing the role of industrial efficiency can play in helping to comply with emission targets under the Clean Power Plan rule and how to count these emission reductions. And here's a bit of an overview on what we're planning to cover today. Megan will cover the first few bullets, and then I'll come in after and discuss the Clean Power Plan aspects. And now I'm going to hand things over to Megan.
All right. Thanks, Cassandra. Thanks, everybody on the line for joining. I'll just jump right in. One of the reasons that we see the industrial sector as a significant opportunity to save energy and reduce emissions is because it's the largest consuming end-use sector in the United States. So in 2015, it accounted for 32% of all energy consumption, more than the transportation, residential, and commercial end-use sectors. So when we say the industrial sector, the definition typically means to include 4 subsectors: agriculture, manufacturing, mining, and construction, with the manufacturing subsector really being responsible for the most, about 3/4 of industrial energy consumption. Looking to the future, the share of industrial energy consumption is expected to increase. EIA forecasts about a 20% increase in the next 10 years. So as energy use grows, we can expect to see increased investments in new manufacturing plants and renovations at existing ones, which means it's a good time to be thinking about and prioritizing investments industrial efficiency. The industrial sector already has a lot of experience and a long history of reducing its energy use. It's unique among the end-use sectors in that its energy intensity, which is the purple line in this graph, has declined consistently over the last 35 years, even as industrial energy use, which is the orange line, and output, which is the blue line, those have kind of fluctuated over time with economic activity. But while industrial firms have continued to become more efficient per unit of product output, they have a lot of experience making these kinds of improvements. We know that there are still many more opportunities to capture cost-effective energy savings. There's a couple of studies from DOE recently and also ACEEE, McKinsey, others that suggest that industry can move forward, increasing its efficiency at a faster pace. DOE's recent study said possibly anywhere from 15 to 32% before forecasted consumption. So just to say that there's a lot of future opportunity. So why do we care about achieving these savings sooner? There are a lot of benefits to be captured, and the benefits accrue to both the industrial end user themselves and to society more broadly. So for the end user, efficiency yields things like lower operating costs, having better control over your energy use results in increased productivity and better competitiveness. And these benefits translate into broader benefits that can help achieve public policy goals at the state level, for example. So just given the scale of industrial operations, a single energy efficiency improvement could have a really large savings impact. That means it could also have a really large greenhouse gas reduction impact. So an important part of what we want to be talking about today. In addition to reducing CO2, efficiency can be a good economic development tool. So when states and utilities offer strong opportunities for businesses to become more energy efficient, that can help retain businesses and attract new ones. And last, when industry is more efficient, power plants run less, it decreases costs for utilities and results in lower energy bills for all customers in the system. So it's really in order to capture these mutual benefits that states decide to work with utilities to implement programs for customers in their states, and specifically to offer programs that are targeted to the industrial sector. What are industrial energy efficiency programs? They have been around for decades, operating with varying degrees of effectiveness and financial support and market penetration, but basically these programs are financed by a small charge paid on monthly customer energy bills. The local utility or a third party, like a nonprofit or a government agency, administers the programs. And the funding is used to provide things like incentives, rebates, technical assistance, engineering assessments, other kinds of services to help customers do energy efficiency projects in their facilities. This is a slide that I borrowed from Eversource Energy, who is one of New England's largest energy providers, and I've included it in today's presentation just because I think it helps demonstrate the fundamental role that industrial customers play in utility programs. So among all the customers served by Eversource, only 2% account for about 80% of total energy demand. That means that by establishing good relationships with just a few of the largest energy users, that utility program administrators like Eversource can often access a really large savings opportunity. And this leads to another key characteristic of industrial energy efficiency programs. They offer the biggest bang for your buck. So we know that savings from large customers can be acquired at a lower cost than programs targeted at other sectors. And in this slide, we're trying to look at two things: the size and the cost of a selection of utility programs for large customers. This data was from the year 2014. So in the pies, we can see that more than half of total program savings are coming from the commercial and industrial sector. And just as a side note, few program administrators separate out data for commercial and industrial. So here we're assuming C&I sector data is generally representative of large energy users. So looking back at the pies, we can see that some states, especially those with a long history of offering industrial programs like Oregon, where Energy Trust runs programs, or Wisconsin, where they have focus on energy, they're getting a lot of savings from the C&I sector. The variation is probably due to a whole bunch of different things. It could be differences in the savings potential. They could have specific regulatory requirements, but I just want to point out that the availability of well-administered efficiency programs that respond to the needs of large customers plays a big role in being able to achieve a large percentage of savings from the C&I customer class. Beneath the pies, in the gray bar, you'll see levelized cost of savings from these programs. This is just 1 year's worth of data, but all of them were less than 3 cents per kilowatt hour. And so that means compared to building new generating resources, investing in programs for large energy users is at least half the cost of building a new power plant. If you want to build a new combined cycle natural gas plant, I think that has a levelized cost of around 7.5 cents per kilowatt hour. So just to summarize, the size and the cost effectiveness of large customer savings is what makes this an important segment. It's often the cheapest energy resource available, and when it's not captured, the utility has to go out and acquire other more expensive resources. And if that doesn't happen, if those resources aren't built, their costs don't need to be recovered, it keeps bills low and saves money for all customers in the community. So one of the criticisms of these programs is that industrial customers are already going to invest in all the cost-effective energy efficiency on their own because it's good business practice. And we've seen data suggesting that they do. I just pointed out that industrial customers have a long history of becoming more energy efficient. But we think it's kind of unlikely that all the measures that would have been done through program participation would otherwise get done without the programs, since the programs help provide shorter payback periods for investments. They include access to technical assistance and other engineering expertise that wouldn't otherwise be available. So that's what this graphic is intended to show, of how the combined investment of industrials and utility program dollars helps widen the window of what could be considered cost effective, and it reduces the payback period of projects, which makes new savings potential possible. So in the yellow chunk, we hear from a lot of large customers that investments in efficiency have to realize short 1 to 2 year payback windows. But by contrast, utilities have more flexible investment requirements. They can tolerate longer payback periods. And we think that's because their business model is designed to make large-scale investments in stuff like infrastructure, power plants, transmission lines, things that have a much slower return on investment. So that means utilities can be more patient. And the outcome is that when you add utility program dollars into the equation, they can help fund really good efficiency projects at industrial facilities that have medium-term payback periods, maybe those that fall in the range of 3 to 9 years or longer. So it's the combined investment of utility incentives and industrial program dollars that makes new savings possible, and it helps projects that might not quite meet the customer's hurdle rate go forward. So reduced payback periods is just one of the ways that programs provide value, and here I just want to take a minute to reiterate some of the ways that utility programs provide value to large customers themselves. I think it's important to note that sometimes participating in programs can be the catalyst to identifying the projects rather than just being the incentive to implement them, which can be very valuable. And for some facilities, the access to technical expertise and project implementation support through the program is worth a lot. Program administrators can make recommendations. They can do the kind of analysis that's needed to estimate the costs and savings that help get internal approval. We also find that programs lead to additional benefits beyond energy savings. sometimes co-benefits, sometimes called multiple benefits. These things provide financial value, improve safety and health, reduce waste. When everything's working optimally, you tend to have lower maintenance costs. And the last point is one that I already made, which is that participating in these programs has system-wide economic effects that result in lower costs for all customers, including the industrials. That means lower energy bills because the customer is consuming less, but it also means a lower cost of electricity since programs help reduce the need for new supply-side resources. And when they're not built, they aren't recovered in rates, and they result in lower prices. So even with the fundamental role of large energy users and all the benefits of industrial efficiency, there's still some well-known challenges with implementing programs for this sector, in part because all the plants are different, everybody has different needs. They are highly sophisticated energy users, their processes are proprietary, but some still want to do energy efficiency even if the incentives or program cycles of the utility programs aren't perfectly aligned. And so here's where I think that the Clean Power Plan can come in and maybe in a position to help address some of the challenges. Some states have passed state-level policies called opt-out provisions that allow large customers to stop contributing funding for efficiency programs. Those are the states that you're seeing in yellow. And opt-out provisions are really problematic because they prevent utilities from not just from being able to incentivize efficiency, but from measuring it and otherwise accounting for it in any of their planning efforts. So the savings that industrial customers are doing on their own can be factored in. Some states have developed what are known as self-direct programs. These are the states in blue. And these programs typically allow large customers to control how some or all of their fees for efficiency are used, but they don't allow them to opt out completely. There are a lot of different approaches to self-direct, but the best ones, the ones that we would support, include mechanisms to measure and verify savings that result from investments that industrials make on their own so they could be documented. And the ability to document savings is really the key when it comes to working with the industrial sector, and it's one of the Clean Power Plan's key criteria. So it's why self-direct programs that include a measurement component could be an alternative to traditional utility programs. And in some ways, the Clean Power Plan, which also relies on this kind of ability to document savings, could be another mechanism to help states solve some of the challenges with reaching large customers. So it's possible to think of the Clean Power Plan as a more compelling reason for industry to undertake the kind of measurement and verification that states and utilities can rely on when they look to do their resource planning and when they look to reduce their emissions. So with that, I'm going to stop and turn it over to Cassandra.
Great, thank you, Mia. So continuing on with the Clean Power Plan, I'm going to take it back a step or two just to get everyone on the same page. So as most of you probably know, there is currently a stay on the rule, on the Clean Power Plan rule that was issued by the Supreme Court. However, many states are still continuing to move forward with planning and planning for strategies to limit carbon emissions. So that is why we are talking about it today. It's a big opportunity. So in general, EPA's Clean Power Plan, or the CPP as we'll refer to it as, sets state limits for CO2 emissions, carbon dioxide emissions, from existing power plants. And the plants that are required to reduce emissions are electric, fossil fuel-fired plants, existing plants, including natural gas and coal units that meet EPA's criteria that they outlined in the rule. The CPP provides businesses with an extra incentive to ramp up their efficiency efforts because states are tasked with compliance, and the states can rely on energy efficiency as a pollution reduction strategy. And in general, I really want to point out that it's the states that are ultimately on the hook to comply with the rule. So even though industrial energy users are not obligated to comply with the rule themselves, they can reduce emissions from the power sector by reducing electricity use at their own facilities. And we'll talk in a bit how there are incentives that can be available through Clean Power Plan compliance to help large energy users do this. And compliance overall with the Clean Power Plan involves achieving the target level of emissions that EPA set for each of the states. And states in general want to meet these targets as cost effectively as possible. And energy efficiency just so happens to be one of the cheapest and most readily available options to help states achieve those emission reductions. And this might be a familiar chart to some of you, but it's showing that energy efficiency is cheaper because saving energy costs substantially less than it does to meet electricity needs with new power plants, as you can see here. Energy efficiency programs cost utilities 2 to 4 cents per kilowatt hour, and that's compared to generating the same amount of electricity from sources such as fossil fuels that can cost 2 to 3 times more than that. So doing energy efficiency first reduces the amount of new power generation needed and lowers the required investments in new facilities, which ultimately, as Megan was explaining, lowers rates and costs for all customers in the utility system. And large energy users in particular may be concerned that the Clean Power Plan could increase their monthly electricity bills, but companies located in states that use energy efficiency may actually experience lower monthly bills. So what types of industrial efficiency can count? What are we really talking about? Well, EPA actually explicitly encourages states to use energy efficiency for compliance, as a compliance mechanism. And actually in the rule, they outline a variety of efficiency policies and programs that states can use to help with compliance. And some examples of the eligible demand-side efficiency measures can include, but they're certainly not limited to, measures that reduce electricity use in, say, residential and commercial buildings and industrial facilities and other grid-connected equipment. That's the key. As long as you can tie those energy and emission reductions back to the power plant that's being regulated by the rule, then that could theoretically count. And we'll talk about what we mean by counting in a few slides coming up. So as you can see listed here, examples of industrial efficiency can include a variety of things: building efficiency measures, process efficiency and equipment upgrades, improved management practices, and along with other technology investments, including installing combined heat and power or waste heat to power systems. So an important thing to point out here is that these examples vary in terms of scale. They include individual measures, and they span all the way to more coordinated efficiency activities that involve improved management practices. And we'll discuss in a bit how industrial efficiency can count toward compliance and the importance of the state officials, that the power they have in deciding what to credit and then how to further incentivize these types of efficiency for use for compliance. So I want to give an example from our State and Utility Pollution Reduction version 2 calculator, or SUPR 2 as we call it. So some of you might be familiar with this tool, but we're going to show an example of what it can do, particularly for industrial efficiency and highlighting CHP in a moment here. But first, a little bit about the tool. So it's an Excel-based tool. It's easy to use, and it's available for use on our website. You can download it on our website. The link is provided at the bottom of the slide. And overall, users can choose from 19 different policy options and levels to build a compliance scenario for an individual state. And you basically plug in the policies that you want, you plug in the state, and it churns out results that go from 2016 to 2030. And you can see what those chosen policies will get you in terms of emission reductions. So we're talking carbon dioxide, NOx, SOx, also in energy savings, the associated costs as well with those policies. And I want to point out in particular the energy efficiency options that it allows you to choose from. We have annual savings targets, building energy codes, CHP. We also have behavioral programs, broken out, and savings from energy savings performance contracting. But it also, in addition to those efficiency options, it includes a variety of renewable or low to no emitting sources and some emission control options to choose from. So with that, I'm going to hand it over to Megan to walk you through an example from our SUPR 2 calculator for Illinois.
Yes, thanks. We wanted to show a state example from SUPR 2 to give you an idea of how the tool can be used. So the bar on the left shows the state of Illinois' emissions goal, the blue one, set by EPA in the Clean Power Plan. And then we selected two of the options in SUPR 2, the CHP option and a 1.5% energy savings target. And you're seeing the impact of those measures compared to Illinois' goal. But before we go any further, there are a couple of really important distinctions to make here. So I'll start with the energy savings target, which is the dark orange part. Not all of these savings are coming from the industrial sector. I wanted to include that option here to point out that some of the savings that can be achieved with a 1.5% savings target are going to come from the industrial sector, and while there isn't an option in SUPR 2 to disaggregate them, we can help figure this out. So for example, in Illinois, EIA forecasts that industry will be responsible for more than a third, actually about 40% of electricity consumption in 2030. And if we applied a 1.5% energy savings target to the residential, commercial, and industrial sectors evenly, we could assume that industry is responsible for maybe about more than a third of those savings from the 1.5% savings target. So we're interested in helping answer this question about how much savings could come from just the industrial sector in a Clean Power Plan context. And we're working now with partners at David Gardner and Associates to help develop some estimates. So coming soon. The other important distinction to make is related to the CHP option. So we used SUPR 2 to model 10% of Illinois' technical potential for new CHP based on DOE's most recent study. So that's about 1,280 megawatts. So what this says is, even if just 10% of the potential for new CHP were installed, a significant chunk of savings could be realized, making CHP a good emissions reduction strategy for Clean Power Plan compliance.
All right, thank you. And that leads us into compliance approaches. So we know that by thinking through different policy options, what that could get you in terms of emission reduction and associated energy savings. But how do you go about doing that? And what are the options that EPA gives states under the rule to comply? So there are basically two options, two broader categories of options, and with those various details with each. But the first point I want to make before we get into the specifics of either of those options is that industrial energy efficiency can contribute to emission reductions either under any compliance approach that a state chooses. It just differs in terms of how those emission reductions are captured. So the first one that we'll talk through, again, some of you might know this, but just to get everyone on the same page before we then run through an example of a certain manufacturing company and what it would mean to go through and try and get some incentives under the Clean Power Plan. So first, under a rate-based goal. This is one of two general types of goals that a state can choose from to comply. So when we say rate-based, we're talking about a goal that is measured as a rate of pounds of CO2 emitted over megawatt hours of energy generated. And you can see here what types of industrial efficiency more broadly, but we're talking about industrial efficiency here, can count. And that is efficiency installed on or after January 1st of 2013 that is still achieving savings in 2022, as stated in the rule. And 2022 is when the compliance period starts. And so if those particular measures that were installed prior to 2022 are still saving energy and they meet, the criteria. Basically, the state says that they can earn ERCs or emission rate credits, then they can be used for compliance. Now, what is an ERC? An emission rate credit is equal to one ERC is equal to 1 megawatt hour of saved energy in terms of energy efficiency. And electric generating units, those types of plants that we talked about a little bit earlier that are under the hook to comply with this rule, need to acquire ERCs in order to show compliance. So the state can issue these ERCs to industrial energy users that generate, measure, and verify the reductions that they're getting from installing energy efficiency measures. And Megan was talking a little bit earlier about the importance of EM&V, as we call it, in being used for clean power plant compliance. And in this rate-based approach is where we really see that. The other way is through mass-based goals. And that type of goal is measured in total tons of CO2 emitted from the smokestack. So again, a state can choose from either of these two general types of goals to comply from. So in this approach, any reductions that happen during the compliance period can count, quote-unquote count, toward compliance. So anything that's reducing emissions and that can then be measured at the smokestack as reduced emissions automatically count. So you can see a difference here. It's not that you're generating efficiency and then you're getting some sort of credit for it that you can then sell to units that need that for compliance. There's a different type of mechanism here, and that's called an allowance. An allowance is basically a permit that allows EGUs, so those electric generating units, to emit 1 ton of CO2. So one allowance is equal to 1 ton of CO2. And so the importance of those allowances is in who holds those allowances, because then they can be sold to EGU owners who need them for compliance. So states can do a variety of things. They have all of these allowances. The states have them in their possession to begin with. And how they distribute those allowances, to whom and how it's done, is one of the key policy decisions in the mass-based approach. So now we'll walk through an example of how this could work with a theoretical manufacturing company. So let's say a company completes a variety of energy efficiency installations, and just for the example, we'll say maybe that involves energy efficient lighting and some air compressor controls throughout their facility. And we'll say that these measures are estimated to result in 800 megawatt hours in annual energy savings, which would then be theoretically the equivalent to 465 tons of CO2 reduction. And we'll say the project costs $180,000 or so. So not very, these things are not very important, the actual numbers, but just something to use as an example. So there are two broad ways to get some incentives from this. So we'll go through by each approach. We'll start first with this rate-based approach. So we talked about the importance of ERCs, but what would the company have to go through in order to get an ERC? Well, they would first have to estimate the savings that they think they're going to achieve from installing these measures. They're going to have to go through and actually do the installation, and then complete measurement and verification of the savings, submit that report to the entity that will be in charge of generating these ERCs. And then the company will get in their possession the appropriate amount of ERCs. So since we said that they have 800 megawatt hours of savings, then they'll get 800 ERCs from this project. And then what this company can do is go around and sell those ERCs to those EGU owners who need them for compliance, and then in turn use that money toward their project. The mass-based approach is a little bit different. Here we have, I'll go through kind of two broad ways of this company could have an incentive to put toward their project. So as we said, reduced emissions from energy efficiency, industrial energy efficiency, they automatically count in this mass-based approach. So one way the company could receive an incentive is they could get revenue to fund their efficiency project through the auctioning of the allowances. So when we're talking about an auction, that could mean a variety of things, but in general, the state could potentially hold an auction to sell allowances, to an entity, maybe to the EGU owners who need them for compliance. And then the money generated from the sale of those allowances could go to fund a variety of things. It could go toward, helping to fund the ratepayer programs in a state that Megan was referring to, or, for example, it could go toward funding energy efficiency for customers, including large energy users, outside of those ratepayer-funded programs. It could go toward another type of program. So the other way that this company could receive an incentive is by directly receiving the allowances from the state that they could then turn around and sell to these EGU owners and get money from. So when we're talking about allocation of allowances to, say, an industrial energy user like this theoretical manufacturing company, we can be talking about a variety of things, but they all essentially involve giving the distribution of allowances to someone who can then find value in those allowances through selling them. So different types of allowance allocation could be potentially through a set-aside of allowances, where the state designates a portion of their allowance budget to be distributed to certain activities that advance a specific goal or purpose. We could also be talking about output-based allowance allocation, where allowances could be distributed on the basis of electricity generated or demand met, which is often relative to the amount of pollution emitted or fuel consumed. And I think it's important to note here that these approaches of allowance allocation and their associated implications, particularly for energy efficiency, it's an ongoing discussion. But overall, it's useful to think through how the incentive in both a mass-based and a rate-based approach can ultimately make its way to large energy users. So hopefully this helps you think through that a bit. So talked about what the incentive could be, how an industrial energy efficiency could count, but now what, as a large energy user, can you do about it? How can you get involved? Well, we have a few things listed here. You can first and foremost meet with your state officials. And by state officials, we're referring to state energy offices, state air offices in particular. Those are the entities that are actually in charge of submitting a compliance plan to EPA. Also the public utility commissions, the utility regulators in a state, particularly for those ratepayer-funded energy efficiency programs you were talking about earlier. Also the governor, who's kind of the leader in the state and directs those state agencies and what the goal of compliance is, whether to plan or not plan, how to do it, how to go about, and what the goals are for compliance. So you can meet with those state officials. You can also learn about the existing programs that are happening in the state that your company is doing business in. What are the existing incentives? Are there ratepayer-funded programs? Are there other types of programs that are currently happening that could potentially be expanded, that could, help to provide financial assistance for energy efficiency in your state? So also in meeting with state officials, you can discuss the opportunity, as we've tried to outline here, for industrial efficiency, and discuss the types of incentives that can be available in a market-based compliance approach, like we talked about in particularly the mass-based approach. You can also engage in actual compliance plan development. A lot of states are still have stakeholder meetings that they're putting forth. Consider joining in those. And then also network with peers and share information. And I particularly want to point out the Industrial Coordinating Committee listed here. This is an informal group that goes by the name of Industrial Coordinating Committee, and it convenes on monthly conference calls to discuss CPP and other issues. And if you're interested in learning more about joining this group, you can reach out to Megan, who will then put you in touch with the group's leader, Jennifer Kiefer at David Gardner and Associates. So just really quickly, some key takeaways from what we've discussed here. Overall, EPA encourages states to use industrial efficiency, all types of efficiency, and very much up to and including industrial efficiency. Also, industrial efficiency can contribute to savings under any compliance approach, a rate-based or mass-based approach that a state may choose. The CPP crediting mechanism, so we talked about emission rate credits or allowances, can be used to benefit manufacturers. And large energy users can talk to state agencies about the opportunity for industrial energy efficiency savings. So that's it for me, but now we're going to talk about a few resources and upcoming events, and I'll turn it over to Megan.
Great, thanks again. We just wanted to take a couple minutes to share some resources that I think might be helpful for people interested in the topics we've been discussing, and then let you know about a couple upcoming events. Earlier this year, we released a set of fact sheets. There are 4 of them. Each is designed to focus on a particular issue related to achieving greater program participation from large energy users. We wrote a blog post about them called "It's Time to Implement Good Industrial Energy Efficiency Programs in Your State." So you can read more there. You can download the fact sheets there. For now, I'll just say that the fact sheets were the result of about a year-long engagement effort that we focused on in 2015, where we interviewed dozens of stakeholders about the barriers that they faced when it came to industrial energy efficiency programs, and we tried to translate the lessons we learned from those conversations into the fact sheets. There is also a companion white paper that kind of explains more about our experience. That's the first additional resource here. The second resource in this list is a blog post and a fact sheet on the benefits of industrial energy efficiency programs from our friends at the Alliance for Industrial Efficiency. The fourth one in the list is a briefing packet. It was put together by several organizations, and it's a compilation of resources to help states understand the potential for industrial energy efficiency in a CPP scenario. It's geared specifically towards states, but I think others might find it useful. You'll also find lots more stuff on ACEEE's CPP resource page, including a link to our Ask platform, which is the opportunity for states to ask questions about the Clean Power Plan. So events, upcoming events. Several ACEEE staff are traveling down to New Orleans next week for the Industrial Energy Technology Conference. This is hosted by Texas A&M. It's been happening annually for more than 30 years, and I think it's a good opportunity to connect with industrial end users. 2 of my colleagues on ACEEE's industry team will be presenting a new paper on how information and communication technology can increase the role of efficiency in distributed resources and energy markets. That's Ethan Rogers and Eric Junga. And I'll be presenting a paper covering a lot of the topics that Cassandra and I discussed here today. This is the last one. One more thing I wanted to tell you all about. It's an ACEEE conference. It's the 3rd Intelligent Efficiency Conference. It's going to be in Austin, Texas, the first week in December. And there are going to be plenaries and breakout sessions covering how information communication technology, ICT, intelligent efficiency are enabling and changing energy efficiency programs. So if any of these topics are of interest to you, I wanted to encourage you to visit the link below or Google 2016 Intelligent Efficiency Conference, And you can submit your idea for a presentation. The call for topics is open until the end of May. You can also use that link, of course, to register as an attendee or learn more about sponsorship opportunities. So that's all for me.
Great, thanks, Megan. And one more event to plug, which is our next webinar in this series, the Energy Efficiency and Clean Power Plan series. The next one will be on paying for the Clean Power Plan. And we'll talk all about different ways to do that through financial incentives and talk a little bit more on allocation strategies and a math-based approach. So please join us for that webinar next month. And here are Megan and I, my contact information. So if we don't get to any of your questions right now, you can feel free to reach out to us by email or phone, and we would be delighted to talk to you further about anything that you saw here on this webinar, any questions you may have. But now we'll get into your questions for the next 10 to 15 minutes or so. So we've had some questions coming through. Just want to reiterate that you should put your questions through the chat box. Everyone's on mute, so we'll just be going through the questions that way. And feel free to type them in now. We'll try and get to as many as we can in the time that we have left. So the first one that we have is, you mentioned there are challenges to reaching the industrial sector. Can you explain a little more about what some of these challenges are? So I'll direct that one to Megan.
Yeah, so there are a lot of benefits, but there are also some barriers. I mentioned a couple of them to achieving greater adoption of efficiency in industry. Actually, last year, the Department of Energy put together a report to Congress on the barriers to industrial energy efficiency, and that would be a good resource to learn more. There are a handful of specifically financial barriers, especially associated with making the business case for efficiency internally. I think companies have limited capital available. There's short payback periods needed. It's also difficult to quantify some of the non-energy benefits of efficiency investments. So if we could include improved reliability or safety or other kinds of avoided costs in the business case, we might be able to put together a stronger one. There are also regulatory barriers. I think the summary on that is that all plants are different, and everybody has different needs, and a one-size-fits-all kind of approach to reaching large energy users through ratepayer programs hasn't really proven to be the way to go. But there are dozens and dozens of examples of utility programs that are overcoming a lot of these barriers. They're doing it through really good program design, and they have the support of policymakers. So I think if anyone wants to follow up afterward, I could direct you to some good examples and case studies of successful programs, and I could also share the link to the DOE report.
Great, thanks, Ian. Next question we have is, what is the cost associated with CHP that you are assuming could be accomplished for 10% of technical potential? And I should say, this question is particularly talking about the slide where we put up a SUPR 2 results for Illinois and talked about, modeled the 10% CHP technical potential for the state.
Yeah, this is an interesting question, and the answer kind of swirls around making some kind of decision about what's possible compared to what's likely to happen by 2030. So the Department of Energy just released a study of technical potential for CHP. I feel like I'm just mentioning a lot of studies that DOE's done. It's a good resource. It's publicly available online. They found that Illinois had something like 12,000 megawatts of total technical CHP potential. So the estimate of technical potential tells us what's just technologically feasible at existing locations throughout the state based on thermal needs and electric needs. So it's an estimate of the market size, but it doesn't account for the kinds of real-world things like cost effectiveness that impacts whether or not a project gets done. So capital costs, but also regulatory barriers that might be in place or policy changes. any kind of market condition that could influence the cost effectiveness. So to answer the question, we chose to estimate the impact of installing 10% of the state's technical potential, which is a conservative approach. It would be perfectly reasonable, I think, to assume 25% or a third or half. You could even do all of it. It's really hard to estimate how much of the technical potential is going to be cost effective today or will be cost effective in the future. But the Clean Power Plan is a policy factor that could influence how much of a state's CHP potential does become economic to install, and it could ultimately boost the amount of CHP that is actually realized in the marketplace.
Great, thank you. And let's see. Another question coming through, do industrial energy efficiency measures installed after 2022 count towards saving under either the rate or mass-based approach? Short answer is yes. I did emphasize a lot, particularly in the rate-based approach, that measures installed prior to 2022, yet after January 1st of 2013, that are still saving energy after 2022 can generate ERCs to count toward compliance. But certainly, very much so, energy efficiency that's installed after 2022 can be issued emission rate credits. I think it's important to point out as well, and also, sorry, in a mass-based approach as well, so anything that reduces CO2 emissions that can be measured at the smokestack of the units that's reducing CO2 emissions can count after 2022. But I should mention as well, we went through and did an example of how a hypothetical company could get incentives under the Clean Power Plan through either of these mass-based or rate-based approaches. But and particularly in the mass-based approach and in the rate-based approach, it's not to say that this is going to automatically happen for large energy users. States have choices for how they can comply, and so this doesn't come down to, do you want to comply using a rate or mass-based approach? There are all sorts of different questions and decision points that states have to think through when they're thinking through compliance and thinking about the goals that their governor set forth for the state and what they want to achieve with compliance. So when we were talking about how do you get involved, one of those areas was to talk to your state officials and to talk to those who are responsible for putting the plan together and to discuss the opportunity that's available. Because I'll give the mass-based approach as an example. We talked about that key policy question of how do you allocate allowances in a mass-based approach. We can't assume that a state's going to choose to allocate in a way that incentivizes efficiency or even particular types of efficiency. That's something that needs to be communicated to the state officials that are responsible for planning, and there's some education needed on that as well. So I think that's an important point to consider. We had a question coming through about that. And even in the rate-based approach, even though EPA outlines all of these different types of efficiency that can count toward being issued emission rate credits under a rate-based approach, it's still technically up to the state to decide what types of things could be issued ERCs. So that's yet again another way, another reason for interested parties to go and talk to states and get involved in the compliance planning process to talk through the opportunity and the reasons for putting incentives in a certain way in either of these compliance approaches.
Yeah, this is Megan. I'll just jump in really quick and emphasize, just because they can doesn't mean they will. And I think the more that we communicate about the industrial sector as an opportunity and seek effective pathways for how to monetize efficiency savings, I think that is really where we can focus efforts.
Great. We have another question coming through, and Megan, I'll put this to you because I think it was when you were talking about resources. when will a paper on opportunities for energy-intensive industries be available? And I'll just go back. I think that was on the resources slide.
Yeah. Thanks for asking about that. It's a conference paper that I'm going to be presenting next week, and so I think it kind of depends on when the IETC folks make the resources available, but ACEEE can make it available maybe on our Clean Power Plan page, or please feel free to just shoot me an email. Our contact information will be up on the last slide, and I'd be happy to share it with you.
Great. And another clarifying question. When you say industrial energy efficiency, do you also mean to include CHP or combined heat and power?
That's right, yeah. I think all throughout the talk today, in this case, when we refer to industrial efficiency, we're talking about the efficiency that you get from different technologies or measures or management practices that improve efficiency, and CHP and waste heat to power are examples of that. So yeah, we do mean to include CHP, but I can imagine instances where maybe they're separate. A different example of industrial efficiency could be, motor efficiency improvement or lighting controls or all that. There's a diverse set of technologies and practices that could be considered in industrial efficiency, and we mean to include CHP here.
Great, thanks. The last question we'll get to before we wrap up here, close to 2 o'clock, is which states have used the SUPR 2 model, and where can we review the results for the states that have used it? So that's one of the great features about the SUPR 2 calculator, is that anyone can use it, and we purposely tried to make it very easy to use. So I'll go back to the resources page so you can see the link about where to access that. Under the Clean Power Plan resources page, we have a link that directs people to the SUPR 2 calculator. And anyone can download it. It's an Excel spreadsheet. And all you do is plug in a state, plug in the types of policies that you want to model, and then the next tab gives you the results. And we've tried to make it something that is easy to decipher. That being said, we are here to help think through different compliance scenarios to use, to help decipher the results and what it could mean for a state in terms of costs, emission reductions, and how much it can count toward a state's compliance target. So please feel free to reach out to either Megan or I with any questions about SUPR and how to use it. So we're definitely here to help. So with that, I think we'll wrap things up. And thank you all for attending today's webinar. We really appreciate you as an audience. And please join us for our next webinar next month on paying for Clean Power Plan compliance using energy efficiency. And we hope to see you then.